Assalamu alaikum dear students. In this video we are going to do section number 6.4, which is about finding areas of surface of revolution. So as always, we will derive the formula uh, for area of surface of revolution, and then we'll demonstrate it with the help of examples. So first of all, derivation steps. So to find surface area of a solid of revolution, we take a partition and approximate by strips or bands. So this is the interval for which we have to find the area of surface of revolution. Now, while rotating this curve about any axis of rotation, uh, a surface of revolution would be generated. And how to find the area? We just, as we said, we just are going to subdivide these intervals into smaller intervals and cutting it into the strips or bands. So we will focus on one band or a strip, and we'll try to find out the area of covered by this band, and then we'll add them up to find a area covered by the surface. Okay, so this band, just cut it and unroll it. So we will have a shape like this, nearly a rectangle. I said nearly because these lines are of course parallel to each other, but at this point this is not going to exactly uh, the straight line parallel to x-axis or the straight line, horizontal straight line. So because there is a curve, when we cut it, there is a curve, and this curve, for this curve, the equation of the curve is y is equal to fx. So when we revolve this line, so what is the radius of that cross section? Radius will be yk or yi, since the points are pi minus 1 pi. So this radius will be yi. Now, how to find? So the area of this region. This is the length of the region, and this is the width of the region. So length of the region is actually the circumference of the circle, right? For circumference, we need radius. So 2 pi r square, that is 2 pi pi I square, that is 2 pi f x I square. So this is the length. Now what is the area then? This length times this width, and this width is arc length between the points P and Pi minus 1 and Pi. So we know the formula for arc length, so we'll multiply the arc length with this circumference. So we have the area of the strip. Then we'll add up all the areas of all the strips to find the area of surface of revolution. So let's have a closer look to the strip. So this circumference part we have already discussed. So what is the arc length for this piece? The arc length is going to be 1 plus f prime x k square square root. Okay, we observed in the last section, section 6.3. So this is the length of this piece. Okay, times delta xk. And by adding all these areas, we have this sum, and letting delta xk approaches to 0, we have this integral. So this is the formula for the area of surface of revolution. So here is the formal definition of area of surface of revolution. If the function fx greater or equal to 0 is continuously differentiable on the closed interval ab, the area of surface generated by revolving the graph of y is equal to fx about x-axis is equal to integral from a to b 2 pi y, that is the circumference, into 1 plus dy by dx square root, and this is the arc length dx, and we can write it in terms of f as this integral. And if the function is of the form y is equal to fx, then we have this formula, and if the function is of the form x is equal to gy, that is the revolution axis of revolution is y-axis, then our function x is equal to gy. Then this formula is modified like this, which is given in equation number 4. 2 pi x. Now in this case, radius is going to be x instead of y. So, and the arc length is 1 plus dx by dy squared dy. So this is the formula for the surface generated by revolving around y-axis. So here are a couple of rules. In general, surface area is integral from a to b 2 pi r ds. So we just replace this ds by one of these expressions. And how can we choose the expression? If the revolution is about x-axis and y is equal to fx, radius is equal to fx, ds is equal to square root of 1 plus f prime x square dx, and x is equal to gy, we have the radius is equal to y and ds is equal to given by this expression. And if we revolve this around y-axis, then if y is equal to fx is revolving, then r is equal to x and ds is given by this formula. And if x is equal to gy is revolved around y-axis, then we have r is equal to gy and ds is equal to this, right? So this is the basic trick. Alright, find the area of the surface generated by revolving the curve y is equal to 2 square root of x, where x lies between 1 and 2, that is a and b here are 1 2 respectively, about x-axis. So axis of revolution is x-axis. So we just learned the formula for the surface area. This is equal to integral from a to b of 2 pi y square root of 1 plus dy by dx square. Now in this case y is fx and revolution axis of revolution is x-axis, so we are going to use this formula. Now rest is just a matter of calculations. You just have to find all these values, that is differentiate the function by plugging in the values. So we are going to have the surface area, which is equal to 8 pi over 3 into 3 square root 3 minus 2 square root 2. Now next question, the line segment x is equal to 1 minus y. This is the line segment x is equal to 1 minus y, where y lies between 0 and 1. So our limits are 0, 1, lower limit is 0, upper limit is 1, is revolved around y is equal to y-axis. So x is equal to 1 minus y is revolved around y-axis. To generate the cone shown in the figure, find the lateral surface area which exclude the base area. So we just have to find this area of revolution. We are not going to find the base area. So from geometry, we know that what is the lateral surface area of the cone? Base circumference divided by 2 multiplied by slant height, and this is going to be pi into square root of 2. You can verify it using geometry formulas. So now we are going to find this lateral surface area using calculus. So we have to use this formula. For this we have evaluated 1 plus dx by dy square, because x is equal to 1 minus y, that is x is function of y, and we are revolving this line around y-axis. So we are going to use this expression, and r here is x. So this is the arc length in this case. So rest is the same procedure. You just have to evaluate the definite integral in order to find the surface area. And we have the same result. Wow, great. And that's all for today.